So we're going to look at this problem on Sapling. Of the first 6 problems you have on Sapling, all of them except for this one are pretty straightforward. And this one's not that complicated either. So this one is asking you to come up with a set of, ultimately you're looking for 8 constitutional isomers of C6H12O that are aldehydes. And the part of this that's kind of tricky is the way that it wants you to do it. So in this first part, in part 1, it's asking you to draw the structure containing 6 carbons in the longest chain. And if you scroll up to the instructions that are above this, it's telling you that it just wants a 6 carbon chain. It doesn't want you to actually draw an aldehyde here. It just wants 6 carbons. 1, 2, 3, 4, 5, 6. That's it. And then it wants you to draw 2 structures that contain 5 carbons in the longest chain. So this time you want a 5 carbon chain, and there's going to be 2 of them. Carbon number 6 is going to be a branch on the 5 carbon chain. So it could either be in position number 2 or in position number 3. And again, it's just looking for carbon chains. And then it wants 2 structures that contain 4 carbons in the longest chain. So you know there's going to be 2 of those. And because we are looking for C6H12O, we only have drawn 4 of the 6 carbons. So we need to draw 2 more carbons. They could both be on the same carbon, or they could be on 2 different carbons. So those are your 1, 2, 3, 4, 5 different carbon skeletons. Now down here, it's asking you to use the 5 structures that you just drew, the 5 carbon skeletons that you just drew, to come up with 8 constitutional isomers that are aldehydes. So we're going to start with the first one in box I, and we're just going to turn that molecule into an aldehyde by adding the carbonyl group at the end of the carbon chain. For the next set of isomers that you have over here, you're going to add carbonyl group to the end of the carbon chain. The end of the carbon chain could be here. It could be here. Because of the symmetry of the molecule, this up here, that's not a unique spot to put the aldehyde group. So there's 2 options for that first carbon skeleton. And for the other one that we drew, the end of the carbon chain could be here, which is going to be the same as if it were out here. Also, the end of the carbon chain could be there. So we can get 4 different aldehydes from that particular box. There's one of them. There's another one. There's 3. Number 3, and there is number 4. So for the last one, I hope you kind of get the hang of it. We could put the aldehyde at the end of the carbon skeleton, which is right here, not here or here, because all 3 of those carbons are identical. You could put the aldehyde group out here. That would be another place for it. You could put the aldehyde group down here, but not here. And also not here or here. All 4 of those carbons are exactly the same because of the symmetry. So let's see what that looks like. Not very pretty. Uh-oh, I think I added an extra carbon. I sure did. So we have come up with 1, 2, 3, 4, 5, 6, 7, all 8.